Okay, so as in the last video we have discussed about the unit of electric flux and we have taken out the dimension of the electric flux as well. That was ml3 t minus 3a minus 1. In today's video we're going to discuss that when the flux will be maximum, when it will be minimum, when it will be positive, negative, when it will gonna be zero. Alright, today we'll be discussing about the angles between the electric field intensity and the small element of vector area, because as we know that electric flux is nothing but it is the dot product of electric field intensity. Alright, so phi is equal to, it is the dot product of electric field intensity, and that is a vector quantity, dot a small element of vector area, and that is the vector quantity as well. When we're going to remove this dot, we know that what will be coming here will be cos theta. Alright, so electric field intensity, this small element of vector area, and cos theta. Now see, the electric flux will be depending upon this angle which will be between the electric field intensity and the small element of vector area. This angle will gonna make it either positive or negative or zero, or you can say maximum, minimum. Now this flux will gonna depend on the angle between the electric field intensity and the small element of vector area. So today we will be discussing about the angles between the electric field intensity and the small element of vector area, so that we can know when the flux will be maximum, minimum, zero, and positive, negative. We will be discussing about all these. So what is our topic today is angles between electric field intensity, electric field intensity, and the small element of vector area. Small element vector area. Alright, vector area. So today we'll be discussing about the angles between the electric field intensity and the small element of vector area. Let me highlight our today's topic. For that, like the angles between the electric field intensity and the small element of vector area depends upon the cos theta. Alright, all the things which includes the electric flux depends upon only and only function cos theta. Means now we have to see where the cos theta will be positive, where cos theta will be negative, when we'll have the maximum value of the cos theta, when we'll have minimum value, and when we'll have the zero value of cos theta. Now everything depends upon only cos theta. Now this topic is very important in terms of MCQs. You will have a lot of MCQs from this topic. So this topic is very important for the MCQ section. Alright, now when angle will be zero, we know that the cos 0 is equal to 1. We know that cos 0 degree is equal to 1, which means electric field intensity, small element of vector area, and cos 0, which we know that will be equal to 1. So 1 into electric field intensity and the small element of vector area, we got electric field intensity and the small element of vector area. So here the flux will be maximum. Because cos 0 is equal to 1, and 1 into electric field intensity and the small element of vector area, we're gonna get the electric flux as a maximum. Alright, now if the cos is 90, if the angle between the electric field intensity and the small element vector area is 90. So theta is 90 now, and we know that cos 90 is equal to what? Cos 90 is equal to 0. We need to learn some basics, alright? So now electric field intensity into small element of vector area and cos 90 we have, and that we know that cos 90 will be equal to 0. Cos 90 will be equal to 0. So when we're gonna multiply electric field intensity and small element of vector area into 0, since cos 90 is equal to 0, so we're gonna get 0, which means when we'll have angle between the electric field intensity and the small element of vector area as 0 degree, so the flux will be minimum. The flux will be minimum. The flux will be minimum. Alright, so we have seen when the flux will be maximum, when we'll have 0 degree between the electric field intensity and the small element of vector area, and when it will be minimum when we'll have 90 degree, which means when the electric field intensity and the small element of vector area will be placed perpendicularly, which means they'll have 90 degree between them, then the flux will be minimum, since we know that cos 90 is equal to 0. Alright, now if the angle between electric field intensity and the small element of vector area is 180, so we know that cos 180 is equal to what? Cos 180 is equal to -1. Alright, so let's put this inside the formula. So electric field intensity into small element of vector area and cos 180, where we know that cos 180 is equal to how much? -1. So let's put this in the formula. Electric field intensity into small element of vector area into cos 180 is equal to -1, so into -1. So when we're gonna multiply this -1 with the electric field intensity and the small element of vector area, we're gonna get negative electric field intensity and the small element of vector area, where we got that the flux will be negative. The flux will be negative when we're gonna have 180 degree, which means when the electric field intensity and the small element of vector area are placed oppositely, they are placed anti-parallel, so the flux will be negative. Now see, now I'm gonna show you by the help of the graph, right? The first quadrant, the second quadrant, third and the fourth, where the cos will be positive and where the cos will be negative, maximum, minimum, that we'll be discussing in the graph now. So let me make a graph here. It will be easy for me to explain to you guys as well. So here, for example, I have a graph. This I know is 90 degree. This I know is 270 degree. This I know is 0 degree. And this I know this is 180 degree, not -180, however 180 degree. So we know that everything is depending upon what? It is depending upon cos theta, the angle between the electric field intensity and the small element of vector area. So this is the first quadrant. Wait, this is the first quadrant. I'm going to highlight this too. Wait, let me write this. This is the second quadrant. This is the third quadrant. And this is the fourth or the last quadrant. Fourth or the last quadrant. Wait, now let me highlight this as well. First quadrant, second quadrant, third quadrant and the fourth quadrant. In the first quadrant, sin theta, which is also a function, sin theta will be positive and cos theta will be positive as well in the first quadrant. I'll tell you this with the example, alright? Sin theta and cos theta, they both are positive in the first quadrant. Sin theta is positive in the second quadrant as well. Sine theta is positive in the second quadrant as well. However, cos theta is negative in the second quadrant. Sine is positive in the second quadrant, cos is negative in the second quadrant. So both are positive in the first quadrant, sine is positive in the second quadrant, and the cos is negative in the second quadrant. In the third quadrant, both are negative. Sine theta is negative and the cos theta is negative as well in the second quadrant, in the third quadrant, sorry. So both are negative in the third quadrant. If I ask you what is the quadrant in which cos theta and the sine theta both are negative, so that is the third quadrant, and both are positive in the first quadrant. Sine is positive, however cos is negative in the second quadrant. Now in the fourth quadrant, sine is negative, sine theta is negative, however cos theta is positive, cos theta is positive. So if I ask you what is the quadrant in which sine will be negative and the cos will be positive, will be the fourth quadrant or the last quadrant. So the random questions or the MCQ question, in which quadrant the sine will be positive and the cos will be negative, it is the second quadrant. And in which quadrant the sine will be negative and the cos will be positive is the fourth quadrant. In which quadrant the sine and the cos both will be negative is the third quadrant. And in which quadrant the sine theta and the cos theta both will be positive is the first quadrant. Alright, now if you have your angle between the electric field intensity and the small element of vector area is greater than 0, it is your angle, your cos theta, your cos theta is greater than 0. Alright, if your cos theta is greater than 0, then what will be the flux? What will be the flux? Will flux be maximum? Will flux be minimum? Will flux be 0? Will flux be positive or will flux be negative? Let's see this. Now see, greater than 0, which means we're gonna start moving from here. Alright, and we know that here in the first quadrant cos is positive, which means we're gonna have the positive value of the electric flux as well. So the flux here will be positive. Wait, this is phi. So here the flux will be positive. Alright, now if your cos is greater than 90 degree, then what will gonna be the effect of the cos 90 on the flux? Let's see. Now see, if your flux is greater than 90, which means now we're gonna start moving from here, and we know that in the second quadrant the flux is the cos theta is negative, because as you can see here, so if cos theta is negative, which means the flux will be negative as well. So flux is negative if you gonna move from the if your angle between the electric field intensity and the small element of vector area greater than 90. Now what if your if your cos theta is greater than 180, then what will be the effect on the flux? Let's see. Now see, you will be start moving from here since 180 greater than, alright, and we know that in the third quadrant cos is negative, so of course your flux will be negative as well in the third quadrant. So your flux will be negative if you have an angle between the electric field intensity and the small element of vector area greater than 180. But what if you have an angle greater than 270? Your cos theta is greater than 270 degree. What will be the effect on the flux? Now see, your angle is greater than 270, which means you will now start moving from here, right? So which means your angle lies on the fourth quadrant, and we know that cos theta is positive in the fourth quadrant, so of course your flux will be positive. Your flux will be positive in the fourth quadrant, which means if your angle is greater than 270. But what if your angle between the electric field intensity and the small element of vector area is less than 0? Which means you will now move clockwise. So if you'll move here, we know that which means it will going to lie on the fourth quadrant, and in the fourth quadrant the cause is positive, which means the flux will be positive if you will have a angle between the electric field intensity and the small element of vector area less than 0. So cos theta is less than 0, so the effect on the flux will be of course positive, since it will gonna lie on the fourth quadrant. So your flux will be positive phi. Alright, so today I have explained you the angles between the electric field intensity and the small element of vector area in very detail. When it will be positive, when it will be negative, when it will be 0, when it will be minimum, and when it will be maximum. I have taught you each and everything in very detail. In the next video, we will gonna calculate the electric flux due to an isolated system. Alright, in the next video we're gonna go that we'll be calculating electric flux due to an isolated or due to a point charge placed at the center of the circle. So in the next video we're gonna discuss about that. This was all for today.